All right, so if you look at the sine function, I want to point out what I mean by that. I'm really kind of looking at this thing over here. That's a sine function. Now, someone says, why are you doing that? The reason for that is 1 over n. It starts at 1, then it goes 1/2. This is pi over 2 over here, by the way. So, like 1, then 1/2. So it's kind of sailing down. And what I know about that, the sine of those things, it's going to get smaller and smaller. Furthermore, they're a positive. And anyway, what am I doing? I'm squaring them. So this is a positive term series, just like the other one we just did. All right? So what would I do? I think I would, I would steer right towards the limit comparison test. And I say to myself is, you got a square there. I'd probably use, this thing, which I definitely know is a convergent p-series, and just do the limit comparison test. Write it down. What do you write down? Limit as n goes to infinity. That's going to be sine squared, 1 over n. And what goes on bottom? 1 over n squared. All right? I'm going to say, looking at it, I could probably rewrite this in a simple way. I could probably say the limit as n goes towards 0, right? Now, someone says, how could you do that? When n goes towards infinity, 1 over n goes towards 0. So I could write this down instead. Same meaning, by the way. What do I got over here? I got limit n goes to 0. I could write it as sine n over n times sine n over n. I know it's complicated, but let me write down, that the one I do know, the limit as x, a continuous case, all right? And I do need to look at that, by the way. Sine x over x times sine x over x. What about this is 1, that's 1. What's 1 times 1 is 1. Okay, what do I know? This is convergent, that's convergent. Thank you.